Effective nuclear charge. To find the effective nuclear charge of an atom or ion, two variables are important. These variables are Z, the nuclear charge or number of protons, and sigma, which is the screen constant. We use these two variables in the following formula in order to calculate the effective nuclear charge, Z effective. Z is easy to find because it's simply the atomic number of the element. For example, carbon has a Z of 6, nitrogen has a Z of 7, oxygen has a Z of 8, and fluorine has a Z of 9. To find sigma, we have to count the electrons found in layers that have a lower principal quantum number than the valence orbital. To do so, we need to look at the electronic configuration of the element in question. For example, let's look at the effective nuclear charge of the valence electrons in sulfur. We'll start with its electronic configuration. 1s2, 2s2, 2p6, 3s2, 3p4. Sulfur has a nuclear charge of 16. The principal quantum number of its valence orbital, 3p4, is 3. To find sigma, we count all the electrons with a quantum number of 1 or 2. Be careful not to count the 3s2 electrons. Even though they have a lower energy level than the valence electrons, they share the same principal quantum number. We end up getting a sigma of 10. If we subtract this value from our Z value, we get an effective nuclear charge of positive 6. Here's how we solve this kind of question. We start by finding the electronic configuration of the cation. 1s2, 2s2, 2p6. Don't forget that sodium had to lose an electron to become the cation Na+. This is why the configuration is different than a normal sodium atom in its fundamental state, which would have an additional electron to form the 3s1 layer. Next, we identify the value of Z. This is still the atomic number, so for sodium, it's 11. To find sigma, we add the electrons with a quantum number smaller than the valence orbital. For Na+, the quantum number of the valence orbital is 2. That means that we only count the electrons with a principal quantum number of 1. Here, 2 electrons satisfy this condition. In doing the subtraction, we obtain an effective nuclear charge of positive 9. To find the answer, we again start by finding the electronic configuration of the ion. For phosphide, we get 1s2, 2s2, 2p6, 3s2, 3p6. Note that we had to add 3 electrons to phosphorus to get the charge of -3. The atomic number of phosphorus is 15, so Z is equal to 15. For sigma, the addition of the electrons with a smaller principal quantum number than the electrons in the valence orbital gives us a value of 10. Putting these variables into our equation gives us an effective nuclear charge of positive 5.